Hi students. Today we are going to learn about CPU scheduling algorithms. It is a process that allows one process to use the CPU while another process is delayed in standby due to the unavailability of any resources such as I/O etc., thus making full use of the CPU. The purpose of CPU scheduling is to make the system more efficient, faster, and fairer. The operating system maintains the following important process scheduling queues: job queue, ready queue, device queues. Job queue. The job queue consists of a set of all processes in the system. Ready queue. Ready queue consists of a set of all processes residing in main memory, ready and waiting to execute. Device queues. A device queue consists of a set of processes waiting for an I/O device. The OS can use different policies to manage each queue: FIFO, round robin, priority, etc. There are two kinds of scheduling methods: preemptive scheduling, non-preemptive scheduling. Preemptive scheduling. The tasks are usually assigned with priorities. At times, it is necessary to run a certain task that has a higher priority before another task although it is running. Therefore, the running task is interrupted for some time and resumed later when the priority task has finished its execution. Non-preemptive scheduling. Once the CPU has been allocated to a process, the process keeps the CPU until it releases the CPU either by terminating or by switching to the waiting state. Scheduling criteria. There are many different criteria to check when considering the best scheduling algorithm. They are: CPU utilization. It means keeping the CPU as busy as possible. Throughput. It is the measure of work, i.e., the number of processes that are completed per time unit. Turnaround time. The interval from the time of submission of a process to the time of completion. Waiting time. The sum of the periods spent waiting in the ready queue. Response time. The time from the submission of a request until the first response is produced. We have some algorithms. They are: first come first serve, FCFS, scheduling; shortest job first, SJF, scheduling; priority scheduling; round robin, RR, scheduling; multilevel queue scheduling. First come, first served, FCFS, scheduling. This is a non-preemptive process that requests the CPU first and allocates the CPU first. FCFS policy implementation is easily managed with the FIFO queue. Drawback. It is not a good choice when there are variable burst times. This causes short processes to wait for longer ones. Shortest job first, SJF, scheduling. When the CPU is available, the process that has the smallest next CPU burst is allocated. If the two processes have the same length or amount of the next CPU burst. The difficulty is knowing the length of the next CPU request. Preemptive SJF scheduling is sometimes called shortest remaining time first scheduling. Priority scheduling. CPU is allocated to the process with the highest priority. Equal priority processes are scheduled in FCFS order. Priority scheduling can be either preemptive or non-preemptive. A preemptive priority scheduling algorithm will preempt the CPU if the priority of the newly arrived process is higher than the priority of the currently running process. A non-preemptive priority scheduling algorithm will simply put the new process at the head of the ready queue. Round robin, RR. The RR scheduling algorithm is designed especially for time-sharing systems. It is similar to FCFS scheduling, but preemption is added to switch between processes. A small unit of time called a time quantum or time slice is defined. If the time quantum is too large, this just becomes FCFS. Each process gets a small unit of CPU time, time quantum, usually 10 to 100 milliseconds. After this time has elapsed, the process is preempted and added to the end of the ready queue. Performance. Queue large FIFO. Queue small queue must be large with respect to the context switch, otherwise overhead is too high. Multilevel queue. The ready queue is partitioned into separate queues. This scheduling algorithm has been created for situations in which processes are easily classified into different groups. It partitions the ready queue into several separate queues. The processes are permanently assigned to one queue. Generally, it is based on some property of the process, such as memory size, process priority, or process type. So that's it for today's class. We will meet in our next video. Thank you.